What we are going to do today is talk a little bit about networking on our PLCs, which we set up in Sysmac Studio, obviously. What we have on the go is we are going to go over what protocols exactly we support. We're going to dive into Ethernet IP specifics a little bit, just because there are a few variations of it and a few different use cases for it. We're going to do a live demonstration of how you implement Ethernet IP, and we're actually going to do a connection to a third-party PLC. I've got a Rockwell PLC here we're going to set up some tag data links with. I'm going to do a quick, I say quick because it is dead simple to set up, but OPC UA server activation on our PLC, and then we're going to go into a SCADA software program and actually tie our SCADA software to our PLC, pull our tags, and get some OPC UA data that way. Modbus TCP, we are going to do last because it will take quite a while. I'm going to walk through it like I've never done it before. We're going to be digging through the help files, some data layout manuals for what we're talking with, and to wrap it up, we'll just compare the protocols a little bit, and we'll kind of have an open floor if there's anything you guys want to see. So here we go. The communication options that we support on the NJ processor. So the NJ came before the NX, and what we did with the NJ is we made it compatible with communication cards and I/O cards from an older PLC, the predecessor, the CJ PLC. Some of you may be familiar with it. So the idea was you could take the address-based older CJ processor off the rack, you could put a new, faster tag-based NJ processor on the rack and use the same cards. So that means we can use all of these legacy protocol cards still if we want to, and they are specific to the NJ. We don't see them a whole lot. I think I've had a CAN bus application fall in my lap once in my entire time at Omron. Now with the NJ and NX CPUs, they come, or well, we can do, most of these are out of the box with the exception of Modbus RTU. We would need a serial card. But EtherCAT, of course, we went over this quite a bit on our first session. Ethernet IP, MQTT, Modbus TCP. We can do IO link. That will be done with an IO link card. OPC UA, this is not on every PLC. It's on every NX102, but it's an option on some of the other PLCs. And we can communicate directly with an SQL server, which isn't so much a protocol as a feature, but they're often used interchangeably. So it's a pretty cool feature. Okay, so we'll talk a little bit about Ethernet IP here in case some of you aren't up to speed on it. So it's a high-level communication protocol. You see it on data networks. SCADA computers can talk to the PLC with it. It's commonly used PLC to PLC. It's versatile, it's fast, it's got a few different options as far as how we do it, which we'll talk about here shortly. Now, due to it's commonly a high-level network, like I said, but due to its speed and versatility, it's trickled down to a device level, and it's seen just as commonly there, if not more commonly now, I'd say. So remote I/O, drives, that sort of thing. It spans both worlds, which is nice. EtherCAT, that's only going to be on device level. Ethernet IP will be high level or device level, either one. Now in Ethernet IP, we've got two types of messaging, so implicit and explicit. Today we're going to be doing implicit messaging, and implicit messaging is essentially establishing what's called a tag data link. So I create a tag in my PLC, and I tie another PLC to that tag, match up the parameters. I'll show you guys what I mean as we go here. But that will run behind the scenes. That data is going to be updated according to how frequently you set your RPI, your requested packet interval. So it's almost unmanaged in a sense. You set the data link, you tell it how quick you want your updates, and then you're done with it. Now, explicit messaging, this would be comparable to what we're going to be doing with Modbus. So we have to enter very specific address parameters on where this data is located, and we have to activate this function block every time you want to send an explicit message. Okay, so as you can see from the picture here, we are going to be communicating Ethernet IP with a Rockwell PLC. And we've got just a switch in between them, and my laptop is plugged into that same switch. So I'll switch over now to Sysmac Studio. I've gone and erased my processor from yesterday, or the day before, sorry, that we were working on. And with Ethernet IP in Sysmac Studio, there are essentially two steps to making tags available to be pulled by something else. And our first step begins in our global variables. So you may have noticed this on day one as we were digging through here, but when we create a global variable, we have this column called network publish. And if we expand it, you can see there's by default do not publish, publish only, input or output. Now publish only we'll touch on in the OPC UA section. Input means this is going to be an Ethernet IP input variable, something can write to it from the outside world. Output means this is an Ethernet IP output variable, and it can be read from, or we can send it to something in the outside world. So normally in our PLCs, we want to minimize as many connections, data links as we can. So if I made, and I'm just going to whip up 3 quick input variables here. So we'll go with some Booleans, some integers, and some floating point variables. Okay, we'll go with 10 integers, 16 Booleans, and 10 real data types. So now these are going to be coming from the Allen Bradley, so there'll be an input to me. And then we are going to do the same thing, but we are going to make output variables. So we'll have a duplicate data structure coming in and a duplicate data structure going out to keep things simple. Okay, deleted the wrong one. I'm overwriting them, that's one. Okay, so we've created our variables. We've assigned a network publish category as both input and output. Now we need to go into our Ethernet IP connection settings up in the tools menu here. You guys can play along if you'd like. I assume you probably don't have a compact Logix you can play around with, but it might not be a bad idea to have this as a reference in the future. So this particular PLC has two Ethernet IP ports, so I'm going to be going out port 1. And we have two sections here. We have our tags and we have our connections. So first thing we'll do is register those tags that we made input or output variables. And there's a handy little button here that says registration all. So I'll click that. It's detected all of these tags as network variables, and we will simply hit register. Okay, now you probably noticed here that there's a tag sets used out of the tag sets maximum, so 6 out of 32. So each one of these is going to take up an entire tag set, but what we can do to take some of the burden off of this and not use up a tag set for an individual tag is we can group multiple tags into one tag set as long as it's under 600 bytes in length. So I'll simply drag and drop this one up here, drag and drop this one up here, and then we'll delete these empty shells of tag sets. So now you can see my tag sets went down to 4 out of 32. So I'll go and consolidate my outputs now. Now I could have built a custom data type with these in it and I wouldn't have had to do this process, but that would have taken a bit more time than we have today to show you guys how to do all that, walk through it. So I've essentially made my own data type just by combining these tags into a tag set. And you can see here that I've got the size of this variable, the combined variables, I should say, and it's identical on the input and the output. Now, to access this on Ethernet IP from the outside world, we need to assign what's called an instance ID. So by default, it's set to auto, but I'm going to give it a number. So I'll give the input tag set 100. I'll give my output tag set 110. Okay. I will go online with my PLC. We're done here on the Sysmac side for this tutorial, and I can transfer this to the controller right here, or I could do a full synchronization and transfer it that way. What's nice about doing it here is I can actually transfer it in run mode. I don't have to cycle power on the PLC or switch it to program mode, anything like that. So changes to your Ethernet IP settings can be done online. Very handy. So I'm going to leave that there. The PLC, I think, is in run mode. I was playing around with it earlier, I'm not sure. Yep. Okay, good. So we're done on the run side. What's up?
Can you explain the instance and why? Like, do you need to set that? Like, what does it mean and why do you have to set it? What is it?
It's essentially the address that this data resides in. It's the equivalent to like a Modbus register address. So when we're looking for this data with the other PLC, we're going to reach out to this IP address at the Ethernet IP port, and we're going to be asking for instance ID 110, and we're going to be looking for a 62-byte chunk of data. So we could have, I could cut and paste this 5 times. I could give them each unique instance IDs, and according to what the other PLC is looking for, we'll pick and choose the instance ID. So it's a data address, pretty much, is the best way to describe it. Does that make sense?
Yeah, it does. So you just kind of position it in the register, and then they'll tell the other PLC where to access that data and how many bytes to get. Thanks.
Yep. Yeah, exactly. So right now we just have these exposed. We have instance IDs assigned to them. The actual polling PLC, we're gonna do that on the Rockwell PLC. So we'll switch over to that, and the instance IDs might make a bit more sense once we're done over on that side. Okay, so here is RS Logix 5000. I've got a Compact Logix L16 ER PLC here. So down on our Ethernet, we are going to create a new module. And Ethernet IP has become a lot better as far as third-party compatibility in the recent years. So I can actually use just a generic Ethernet module, according to Alan Bradley, just a generic module. You fill in all the details, sort of thing. Any Rockwell programmers out there are pretty familiar with this one, I'm sure. So we'll create a generic Ethernet module, which is a generic Ethernet IP connection. I'm going to give it a name, NX102. The IP address here is just the IP address of port 1 on my PLC. The data type, so this is where we'll need to do a little bit of a workaround. If I did 3 individual connections for all 3 of these data points, then I would just specify Boolean, integer, and real, and I wouldn't have to do anything with the data on this side, but I didn't want to take up 6 connections. I just wanted to take up 2 connections. So we're going to do a little bit of data manipulation on the Alan Bradley side. So I'm going to just stick with data integer. It's pretty easy to work with. Now here, Adam, is what we're looking for. The assembly instance, we call it the instance ID. Now in the Rockwell, or I shouldn't say the Rockwell world, this is my output is the Rockwell PLC's input. The Omron's output is the Rockwell's input. The Rockwell's input is the Omron output. So my instance IDs are going to be swapped here, is all. So my output, you can see, is 110. It's 62 bytes. So my input is going to be 110. And that would be 31 words of data. We're dealing with 16 bits here. Bytes are 8 bits. We just divide by 2. The other assembly was 100, and it's the same length. Configuration is just 1, and it's 0 in length. Okay. Easy enough to set up. I'm going to transfer this to my Rockwell PLC now. It is not quite happy. So let's see what it's complaining about. Connection point symbol.
What's the bit selection check mark do, Stuart? Maybe I missed that.
Oh, they're Booleans, so you can work with individual bits. That's all that is. It's a default when you're sending or receiving Boolean data. So.
Okay, gotcha.
Interesting. I did this yesterday. Didn't have any issues. 50.1. think I have my instances right. My output is 110. The input is 110. It is 100. Okay. I think it's a speed thing. Okay, that is a bit odd. I apologize. This worked this morning for me. I'm going to try a full synchronize on the Omron side.
Hey Stu, where did you get your input and output numbers on the Allen Bradley side? So 110 and 100?
Those are my instance IDs that I set up in Sysmac. So I just made them 110 and 100. I could make them whatever I want as long as they match up on Allen Bradley side or whatever other PLC you're pulling this with.
So your output at the moment is marked as 110?
Yep. Which will be the input on the Allen Bradley side. I did clear the processor and I haven't done a proper setup on it, so that might be part of my problem. Let's see if I have any errors here. Yeah, that could be causing some issues. So I'm just going to synchronize with the proper configuration on there. Try to eliminate any possible problems. Okay, now we've got green lights. Just going to double check my assemblies here. So my input is 100. That should be output on the Allen Bradley side. Output 100, input 110. Okay. Okay, I was happy about that. So do a proper setup of your PLC. Word of advice. Now you can see we don't have an error on our module. We've detected on the Allen Bradley side that it's an NX102 1220 we're talking to. And it's happy. So we can look at our actual data here in the Rockwell side in our global variables, our controller tags, they call them. So let's see here. NX102 input and data. So because the mapping doesn't really match up, our first word of data here over on the Allen Bradley side is going to be our Boolean array on the Sysmac side. So I'm just going to flip a few bits over on this PLC. So we'll go to a watch tab page table, which lets you drill down into arrays. So it's the Boolean 2 Allen Bradley. Here's all my bits. So I'll flip the first 2 bits and I'll flip the last bit. And then we should see on the Rockwell side, let's go to monitor, expand, and there you can see the first 2 bits are 1 and the last bit is a 1. So our Booleans work. Integers are going to be easy because it's the same data type. So the integers to Allen Bradley, we'll just type something in here to test, 1, 2, 3, 4, and our last integer, 5, 4, 3, 2. So here we've got 1, 2, 3, 4, 5, 4, 3, 2. Now the floating points, this is where you need to do a bit of manipulation on the Allen Bradley side because the data types really don't match up, but it's not too hard to do. We'll just look at our reals to Allen Bradley. So we'll just put in a decimal value, 123.456, and it's going to look very funny on the Allen Bradley side. Takes up 2 integers because it's a 32-bit data and it's displaying it with 2 16 bits. So that's easy enough to just copy into a floating point on the Allen Bradley side. So it starts at variable position 11. So we could have made a UDT on both sides, match them up and saved us this portion, but so I'm just going to convert it on the Allen Bradley side, and as I mouse over it, you can see that same value that we typed in, 123.456 is there. So I could have converted the entire array in one go if I wanted to, but this is just for demonstration purposes. There are a number of ways to do it. So, and obviously sending back data back to the PLC, I can just write directly into the output tags here. So these are my Booleans. So I'm just going to send a couple ones over. my Booleans, and you can see I've got 0, 1, 2, and 4 flipped, which matches what I have over here. So integers, no problem. Floating point, I would have to repeat this copy procedure in reverse, essentially copy a real into the output array. But you guys get the idea. So generic Ethernet module in the Rockwell PLC. In the Omron side, all we did was expose these variables, give them an instance ID, and we simply just tied the Rockwell PLC to those instance IDs. We matched the data size, and we got our communication. So we can speed up or slow down our comms according to who's polling who. And in this case, the Rockwell was asking at a 100 millisecond interval. We could speed that up to 1 millisecond or slow it down much slower. So any questions on the Ethernet IP implicit messaging?
No, Stu, that was great. It was actually good to see, having some issues so we can troubleshoot it. Kind of a real life experience there. So thanks for going through that.
Yeah, if there's anything I'm good at, it's doing the same thing twice and getting different results. So,
aren't we all?
Good. So I'm going to go offline with the Allen Bradley PLC right now and show you guys something in the Omron PLC. Essentially, how we would. Okay, it's open. Good. So we'll disconnect here. Now, in our Omron PLC, in our Ethernet IP setup window here, we can leave all of these tags that we were using for the Allen Bradley in here. They're not hurting anything because we don't have them linked to anything. They're just exposed. Now, if I wanted to connect to something, say it was something third party, this is where I would load the EDS files. So I've got a few different things in here. I've got some microscan smart cameras. I've got some Moxa protocol converters. I've got these oddball servo drives that I was playing with, some Schneider drives, that sort of thing. So we can load our EDS files in here. And then when we actually want to use something, I'll just add something here. So in that example, the Rockwell PLC was initiating the communication. So in this example, I don't actually have another Ethernet IP device here that I can link up with, but I'll show you guys the process and how you kind of work from the EDS file backwards. So punch in an IP. So in the model name here, this is where the EDS file will be accessible. So I'm going to pretend this is just a smart camera, FHV7, and I'm going to add it to my project. So this is where we'll actually dive into the connection tab. So in the tag sets, we can make tags available. And in the connection tab, this is where we actually become the master and we can make a data link with something versus having something pulled from us. So I'll add that device. And the EDS file had a number of instance IDs. I'm just going to go with the first one and the first one, sure. So you can see here, according to the EDS file, it found these instances and it found the size of the instance. So what I'm going to do now is make an input variable 48 bytes in length and an output variable 20 bytes in length. So I'll do that in my global variables. output was 20. So I made these Word data type, but I could do the exact same thing that I did by grouping the various data types together. I could make my own data type. That's often what we do in these situations. We'll have a data type available on our website that you can download for the FHV7, for example. And it has all of these 48 bytes properly mapped and labeled, and they're much more accessible. So when I make a new global variable that happens to be a network variable, I do need to register it. So I'm going to assign these input and output. I'm going to go back to my Ethernet IP tags this time, and I'm going to register all of the new ones. Ignore most of those. So here it's auto-detected a variable of that size, FH input and FH output. So now I would transfer this to the controller, and I would now become the scanner class device in this communication setup. So I would be pulling data from the FH and writing data to the FH with these variables, FH input, FH output. Don't have one with me, unfortunately, so I can't demo it, but that's the idea anyways. Load the EDS file, make a connection with the device, and then it tells you what instances are available and the size of the instance according to the EDS file, and then you simply make your tags and transfer it to the controller. Any questions? Everyone still awake?
We're here following along.
Yeah, it's really interesting, Stuart.
Yeah, so that's implicit messaging. I'm not going to do an example of explicit messaging. I can't remember the name of the function block, but explicit messaging you would do in your ladder program according to communication sheets, data sheets you'd find online. So
Where does someone need to use explicit messaging compared to what you showed?
some devices only support explicit messaging. And as well, if my tag sets here, if I had these maxed out, if I had 16 drives on this network, I could do an explicit message to something if I didn't need to use a data link and it supported it. So in theory, you could have a lot more devices on the networks if you weren't using tag data links and you were just using explicit messaging. A number of reasons, yeah. Some things don't support it. You can cut down on your network traffic, and yeah, you might not need updates every millisecond from something. So, does that answer your question?
Yeah, that's good.
Okay. Yeah, I'm just going to leave my Ethernet IP alone because I'm still communicating with the Rockwell PLC. So I'm just going to leave it at that. Okay, OPC UA. This is included as a standard on our NX102 PLCs. Yeah. Back up. Back up. Okay, an OPC UA is probably the easiest one we're going to do today. So you may have noticed in our multi-view Explorer, we have a category called OPC UA. Shrink everything down here a little bit. So we've got OPC UA server settings. So we double click on that. All we really have to do here is check off use. And now it tells us the port we want to use, and it even gives us the URL for the endpoint, this server's address. So it's not happy with this logic. Okay. So I'm just going to go online, enable the OPC UA server, and then we're going to have to reset the PLC. Okay. I'm not sure why it's not happy with that. Oh, yeah, okay, my mistake.
Is delete a reserved name or something? Why did that trigger an alarm, Stuart?
I made a variable and then I didn't use it, and I didn't assign it a data type. Okay, so it's telling me now that I need to reset the PLC because I enabled the OPC UA server. So I could physically unplug it, or I could put the controller into program mode, and I can do it right from the controller menu, just reset the controller. Take 10 or 15 seconds to boot up here. Okay, so this OPC server is now running. I can check the server status here. It tells me it's running. This is the URL that I'll need to use in the client that I want to talk to the OPC UA server with. If we wanted to have a secure connection, we can support all of these types of encryption, and we can also just do basic username and password security. Right now I have security completely disabled, so that's the default. And what we're going to do is use Omron Indusoft, it's our SCADA offering, to connect to our OPC UA server. It's just loading here. Okay, so in Omron Indusoft, we've got a drivers tab, and by default it had OPC DA, OPC UA, and OPC.NET, and a few different other ones. So I went and added the connection to our NX102 under the OPC UA connections, essentially made a driver for it. And this endpoint should look familiar to you. That was cut and paste directly from Sysmac Studio right here in our server status. I can test the connection. It says it's successfully established. Okay. And then I can browse the tags that are on my NX102 PLC. So if I go here and click browse, I can look at my NX102, I can look at the global variables, and here is everything that I made accessible on the network. So these should all look familiar. We created them in the Ethernet IP exercises. Now if I were to add a variable online in my NX102, I'll just go down to my global variables, start and online edit. Create a new variable. This will be online variable. And we'll make it real, doesn't really matter. We'll make sure that we publish this variable. Send our changes. Now our OPC UA server, I'm just got to rebrowse it here so it gets a new tag list. Our OPC UA server now picks this up, our online variable. It tells us the data type, it auto detects it. When we're dealing with arrays, like all of our Ethernet IP variables here, it auto detects that it's an array. It auto detects that the number of items in the array, that sort of thing. And if I actually wanted to read a value, I've got, let me just choose another one here. I will choose the new one that we made. Okay. Now, if I change that value in my PLC, I can see it change on the on the SCADA systems. That's the table. So change this to I need to make a new one here because there's a data type mismatch there. That was left over. So I'll just call this one my online variable. I'll browse to that new variable. It's going to be a real variable. Save it. It doesn't want to grab my value right now, probably because my application isn't running, but that's the idea with OPC UA. We're now dealing with tags instead of addresses. We can look and we can detect all the variables on our PLC by tag name. This is how InduSoft does it. OPC UA is a pretty open protocol and a lot of people implement it. I can't demonstrate it on every platform, obviously, but that's OPC UA. It's pretty simple. The tags work on a subscription basis. So out of these 10 or so tags that I've subscribed to, if only one of them were to change in a given communication cycle, which I have set to 1 second, it would only send one value over, and it would simply send a keep alive for the rest of the values. So it doesn't flood your network. It's very efficient in that sense. You might have data that's stagnant for days, even weeks, and we don't need to update that every second.
So Stuart, the value didn't update for online variable. Why is that?
I think it's because I haven't run the application.
Can we demonstrate how to fix that?
I mean, for the most part, everything's already configured in Sysmac for this. Like, it's very simple to set OPC UA in Sysmac. This is just troubleshooting an InduSoft communication.
Yeah, the database spy I've had some luck with. I'm curious if I can write with it. I'll register that. Yeah, no, it's more of an InduSoft thing. Yeah, I haven't run the application yet, and I'm not sure I can with the trial version, but it will let me set up the OPC UA server, and it will let me browse my tags. So that's the main point I wanted to get across. Okay, so that's OPC UA in a nutshell. I'm not an InduSoft guy, to be honest. I'm a Sysmac guy. So we'll take a 5-minute break there. Feel free to punch in any questions you might have on the chat, and we can get to them when we come back. So use the washroom, grab a coffee, whatever you need to do, and we'll come back in 5 minutes on the hour here. Okay, we'll kick it off again here. So what we're going to be doing next is Modbus TCP. What we're going to be talking with is an S8 VKX power supply that Omron makes. So this supports Ethernet IP and Modbus TCP. We're going to be using Modbus TCP. And I'm going to be doing this like I have never done it before, on both, you know, talking to it with something else or doing Modbus in Sysmac. So I'll show you kind of the process that I go through when I connect Modbus TCP with something that I've never talked to before, as well as the process I went through when I was figuring out how to do Modbus on our PLC. So first thing I did was went to our website. We've got a communication manual for the S8 VKX. I've got it open here. And I scrolled down to essentially what we're looking for in our Modbus functions. So the main ones here are the unit ID, the function code, the start address, and the number of words to read. The rest of these we don't actually do anything with. So there's our register address list here. So it looks like we need the first 10 words of data. And we're going to be using a multiple register read, which is function code 3. Okay, so I'll keep that open and I'll go into Sysmac here. So I've got a blank program, and in the toolbox I can simply search Modbus. It pops up the different Modbus options that I have. So I've got RTU read, RTU write, TCP read, TCP write. I want TCP read, so I'll drag and drop this out here. I'll give it a name. I know that function blocks need names, so this will be, call it MB TCP, and it's going to be a function code 3, so I'll call it FN3. Okay, so I've got all of these input and output parameters. I'm not really sure what they do. So if I mouse over them, this is looking for a socket, this is looking for a unit ID. That makes sense. Read command, this is a data type that's unfamiliar to me. Modbus read is the data type. Read data, that's just going to be an array, I know that. And timeout, that's pretty self-explanatory as well. So I'm going to open up the help file because I'm not sure what socket and socket and read command are. They're their own data type, and chances are I need to dig into them and access the actual members of that data type. So I'll hit F1. It's over on another window here. Okay, so socket is its own data type. Read command is its own data type. If I keep scrolling down here a bit, it looks like this is I'll go to the programming example here. So here we've got a structured text programming example, and it looks like that we need a SKT TCP connect block in order to generate a socket variable. So I'm going to search for that block on here, SKT TCP connect, right there. And I'm going to want to do that first, so I'll put it kind of in a chronological order here. So I'll put my TCP connect block up here. I'll give it a name. Okay, source TCP port. I'll go into my help file. So it looks like where is it? There it is. So this is the local TCP port, and it looks like the default is 0. And if I leave it at 0, it finds an available port. That works for me. Destination address, that makes sense. That's the IP address. Destination port, that's always 502 in Modbus. And the socket, here's that variable that I was looking for that I need to pass onto my Modbus block. So that makes sense. So TCP port, I said we can leave that at 0. The destination address, I know the IP address of my power supply, so I enter that like this. Just gonna make sure it hasn't changed here. That looks good. Destination port, Modbus is 502. And socket, here's that data type that I need to pass on to here. So I learned that in the programming example and help file. So I want a contact that I can activate this with. I'll port. And if it is successful, we'll make a variable called port open. And we'll put some variables here just in case we get an error, we can see what it is. Okay, so if I did this correctly, this should start detecting my Modbus socket variable as I start typing it. So there it is. Okay, one down. Our socket is down. Now we need our unit identifier. We saw that in the communication manual that it was 255. What is it here? Yeah, unit ID, FF, and hex is 255 in unsigned integer, which is what this is looking for. Unsigned single integer, so a byte. Now read command, this one I can drill down into the parameters either once I create this block and do it online, or I can write to those parameters ahead of time. But I'm going to look at the help file and see exactly what that requires. Okay, so here's read command. It looks like it's got 3 members. The function, which is the function code, we've got 4 options here. Coils, discrete inputs, holding registers, input registers. So probably familiar to those who have dabbled in Modbus. The read address, that's good, and the read size. Both of those we found in that communication manual. So the easiest way to access those parameters, well, there's a number of ways. The way I like to do it, so we'll make a variable for read command. We'll just call it function 3 read command. So we could access the members down here in our data watch window. If I just punched in, I made it a local, so it's going to be program 0 dot function 3 read command. So you can see here I've got the function, the read address, and the read size, just like we saw in the help file. What I like to do is just throw an inline structured text box above it, and then I can just manually write to those. And then I've always got that there as well if I want to change it easily, or if I want to just see what this particular structure has inside of it. So I'm going to do it in structured text. We can embed structured text in our ladder logic in Sysmac Studio, so it's useful for equations, or if you can't decide which you prefer and you want to do a mix and match, you can do it that way. So we need to edit the members of function 3 read command variable, so I'll start typing it. So there's our function 3 read command dot function equals. This was in the help file. I just know this because I've done it so many times. So there's read holding registers. That's function 3. The read address. If I remember from the manual that it starts at 0. And the read size, I remember from the manual, was 10. So 10. So now I can see exactly what I'm doing with this Modbus block just by looking at this structured text block. It's very well laid out for me if I want. Alternatively, I could drill into it with my data watch table here and see it that way. Okay, now read data. I'm gonna double check what that will accept in my help file here. So here's read data, and it looks like it needs to be an array. It can be either a Boolean array or a word array. So I'll go with words just because they're very versatile in Sysmac Studio. So I'll make an array here. I'll call it power supply data. And because it didn't specify a data type in here, this is going to ask me what I want to make it. So it will be word and size. As long as I'm equal to or greater than the data that I'm pulling, we're okay. So I'll just make it 20 to be safe. Timeout, back to my help file. Timeout, is probably went too far. I did go too far. Okay, so tenth of a second increments. The default is 20 or 2 seconds. I'm okay with that. And that's looking for a unsigned integer. So I'm just going to do it as a constant. So unsigned integer 20. I'm going to go with the suggested default. And we'll put in some bits in case we get an error, we can see it. Okay, so who thinks this will work first try based on my track record? I think my chances are about 50-50. I'm gonna go online, I'm gonna synchronize. Okay, so first thing I'll have to do is open up my connection, establish the connection to port 502. And if we're successful, we won't have any errors here, and this bit will be true. It would have been smart to take this bit and utilize it on this rung so we won't try to execute this command unless our socket's actually open. But the next thing we'll do is activate our Modbus TCP read block with this bit here. And it looked like it passed, that's good. It tells me that it read 10 variables, which is what I asked for, and it didn't give me any errors. So let's look at the data we're actually getting from it and see if we can make any sense of it. Okay, so we definitely have data. We've got 0 through 9 with some values on them. So if I look at my manual for my power supply, I can see that the first value is going to be the status, which is going to be a little weird because it's just Boolean data. So the number won't make any sense unless I look at the actual bits. But this one here, output measured voltage, and it looks like it's a multiple of 10.1 volt increments. So that would be a good one to test with because I can change that on my power supply and verify that this number here, oops, switch the view to decimal, I can see this change as I change the voltage just with a screwdriver here on my power supply. So I need this to update. Every time I flip this bit, it updates, but I don't want to sit here and flip this bit over and over and over again. So what I'll do is just a quick online edit, and I'll put a 1 second pulse in here, and that will do it for me. So we've got a bunch of different pulse bits we can use in our ladder logic. I chose the 1 second. Transfer that, and now we should get some up-to-date data on a regular interval. Let's go back to our table. Let's look at it in decimal. So this is our voltage, 2530, which is 25.3 volts. So I'm gonna step away from my computer and bump that down to about 24 volts, and we should see that number update on here. Okay, 23.9 matches the power supply, so good. That was successful. Now, Modbus is obviously a lot different than other protocols. Ethernet IP, we set it up in here, and then we just left it alone. It handles the communications, it handles the troubleshooting. If there is a problem with Ethernet IP, it would actually give me an error in my event log and my troubleshooter. Same with OPC UA. So with Modbus TCP, we need to essentially monitor it ourselves and control the intervals ourselves. I'm controlling the interval just with a pulse bit, but if I were to lose the connection for some reason, let me just close that. Oh, I'd have to reset my socket. Yeah, so it's actually working because my socket was populated properly. But if we were to lose this, I'll just I'll unplug the cable to the power supply. That'd be a good way to do it. There, so you can see I'm no longer getting a complete communication successful with the power supply. So in Modbus, this is something that we need to keep track of and do something if it happens, right? This could be an alarm. If I attempt, say, 10 times to do a function 3 read and I don't get a completion bit, then notify the operator or reopen my socket, take a break, flush the Ethernet port. There's a number of things you can do, but that's just something you need to be conscious of when you're doing a connection like this. Any questions on the Modbus side?
So there's not data sheets available like the IP that makes it a little bit easier to analyze the data that we get?
Oh, there absolutely is. That's what this is here.
No, but I mean, like, you can't just import like a data sheet into
a data
Sysmac
type?
so that it automatically does stuff with that.
Do you mean a data type? Do you mean?
No, like how you have like a .eds for Ethernet IP, and then it'll basically take all your data and then it kind of analyze it for you, right?
Mm-hmm. Yeah, I see what you mean. Yeah, not with Modbus. No, Modbus is a much older protocol. It has been around long before I was in the automation industry. That's for
All these connections just
Did the connection just drop on us all?
Sorry, I got booted off there.
Yeah, so did I. That's strange.
Okay, as long as it's not just me. Maybe it's a Northwest Calgary thing, Chase. I don't know.
I'm not sure what happened there.
Okay, so we're
Had a server update or something.
yeah, Adam. How much of my rant did you hear before I got cut off? Maybe he got booted too.
We only. Okay, did it drop again?
I think a lot of people got kicked off there. Can you hear me, Adam?
I hear you.
Yes, where are you?
Kick me out. Everybody back in here? Can everybody still see?
I see Adam in the meeting, but I can't hear him. He's muted. I'm not sure.
Did it kick everybody out, or was it just myself and Stu?
oh, sorry. I was muted on the computer, and I was trying to unmute my phone. You can hear me okay?
Yeah.
Yep.
Okay, great. Sorry about that, guys. No, I was just saying that, showing how challenging it is to set up Modbus TCP, it just shows the power of the EtherCAT network for how easy it is to get data from couplers over EtherCAT, and hooking up new devices via EtherCAT is really nice. So.
Yeah, Modbus is quite a manual process. This is actually one of the better Modbus documents I've seen for our power supplies. Breaks out your bits, tells you your multipliers and your addresses. Some of them are not as good. For those of you on the call here who've done a lot of Modbus know what I'm talking about.
Also keep in mind, Modbus is a super old technology. You're not going to get the update speeds and things like that. And that being said, to put Modbus into a piece of equipment is a lot cheaper, which is why you typically see, run-of-the-mill equipment all Modbus capable, where EtherCAT is, you have to have the EtherCAT chipset. You essentially have to pay it back off every time you implement EtherCAT into anything. So it makes stuff a little bit more complicated. However, the benefits are, when you go with EtherCAT, the benefits are well worth the money, I think, especially in just initial setup.
I agree completely.
Steven made a comment. The last thing that you were talking about, he was talking about the different things we can do to reset the Modbus if something is not reading. So Steven made that comment.
Look at the chat here. Oh, okay. Oh, Brad Nielsen's got the history down. Very nice, Brad. Yeah, so as a quick comparison, EtherCAT. Here's my vision sensor. Okay, drag and drop. That one's actually going to take a while because you can program the entire thing on here. But here's my OMAP, and here are all of my tags and variables broken down with comments, what they are, descriptions, and I can just literally throw my variables right there, and I've got everything I need ready to go. So yeah, huge time savings with EtherCAT. You don't have to do all of this, right? You don't have to sequence your communications with a timer of some kind. We don't have to look to see if our socket has dropped off or if our function block has an error status. You guys get the idea. It's even with Ethernet IP, that is handled completely behind the scenes, and it's a time saver. So Modbus really is a product of its time, but super common. I don't think it will ever die. So I've kind of had to become familiar with it and used to it. And this isn't the worst implementation of it. The first time you do it, you're in the help file a lot, like I showed you, but really it's two function blocks. If I had another function block, I would take the same socket and I would just put it on a write function block if I was writing registers. Or we have a generic Modbus command function block where you can change the function code depending on if you're reading or if you're writing what you want to do. I think Mike's on this call. He's had a bit of Omron and Modbus experience. Mike, what can you tell us? Maybe he's on the other line. Okay, so we are just about out of time here. I'm just going to do kind of a wrap up on the three protocols that I showed you guys today. So OPC UA, by far the easiest to use. We simply enable the server. The rest of the work is done on the client, which I'm obviously not too proficient in. We use Indusoft, but we are OPC UA compliant. We have members on the board that actually govern the protocol. So third-party compatibility is no problem with OPC UA. Same with Ethernet IP. We are fully compliant. There's a bit more setup involved. Obviously, you need your data links. You may need an EDS file if it's something third party. And the sequencing and everything is handled behind the scenes, at least for implicit messaging. Explicit messaging, far less common, and it would be comparable to what we did with Modbus there. Modbus, you saw what I had to go through. There's a lot of addresses and function codes, and then breaking the data you get into bits and bytes and multiplying it by constants to get the units where they need to be. Quite often you'll develop a custom data type according to what you find in that communication manual. And yeah, that's essentially it, from OPC UA being super simple to Modbus TCP being a bit more involved and a manual process. Those are a few examples of how we communicate with Sysmac. So are there any questions or anything you'd like to see as far as the communications go on these?
Well, Stuart, would it be of value if we showed how to use a .eds for Ethernet IP for just a more standard device?
Load an EDS file on Ethernet IP?
Yeah, and just kind of getting data from that.
Yeah, sure.
That's something I'd like to see.
I think I have some EDS files. EDS files. Here is a I think these are all loaded online. So let me just grab one for, I don't know, Rockwell Drive. I think I have all the Omron EDS files. So my luck, they'll charge me $75 for the EDS file or something.
But one thing too, I was going to ask Stu, is there any gotchas or anything that we do differently or we do better, or is there anything that we can't do compared to the common manufacturers out there of PLCs?
Well, yeah, if we go to the Rockwell side here, there's a bit of a gotcha. So if we threw a new module in here and it was, I don't know, AC drive, sure. So we just threw that into our Ethernet network. Just thinking really hard about that drive right now.
It's giving you lots of time to think if that was the one that you wanted to choose.
And now it wants to install something. Okay, so bad example. Essentially, what I wanted to show you is, and I really won't be able to, it's kind of hard to describe, but if I would have added one of these devices, it would have given me a bit of a broken down data structure. Like if it was a VFD, it would have a frequency and a command, that sort of thing. With Sysmac, you essentially do it the other way. You would build the data type for that drive instead of taking the data type from the EDS file. Now, obviously Rockwell does it very good with their equipment. They don't do it with third-party equipment as well. I don't know, I feel like I've broken RS Logics here. It's just not responding to me. Maybe that one's going to work better. Okay, I'll just give it an IP. Okay, so I added that device. Now if I look at it in here, we've got some predefined tags that it imported with it. It does this with Rockwell items. It doesn't do it with third-party stuff. You have to kind of import the data type and map it all to it. In Sysmac, we just know the size and the location of the data that we're getting. We often have on our website data types that you can download for the devices and pair them up that way. But that's something different, at least coming from the Rockwell side, is we have to kind of break out our own data, or we load the data type for that device. And that's the main one that I can think of. We can do.
So if you load it in the .eds, that wouldn't help that? That wouldn't do that for you?
No, the EDS file for us merely specifies what instances are available and the size of data for those instances. And then you would use that in combination with a manual like this and figure out what goes where. Or you could, like I said, take the data type. We have some data types for some of our devices that you could just load in and do it that way.
Okay. So basically the data types will line up well and it'll say, oh, this is a word, this is a byte, etc. But then you still need to take that data and then assign this word into the power supply voltage or whatever it is.
Yeah, basically.
Even if you have the .eds.
Yeah, you'd still have to do it. You could do it in one instruction, just a very large array copy instruction, move it all into the data type for that device. Just this is, I guess, it's one less step that a lot of people are used to coming from the Rockwell world. So then that's only the case with their hardware. With third-party stuff, you just get raw data back. You have to do it yourself. So
yeah, so this would be equivalent functionality to using Omron with EtherCAT, basically.
Yeah, essentially. Okay.
All right, guys.
We're a couple
If
minutes
nobody
over.
has any other questions, yeah, we're over our time here, so we can wrap this up. If anybody has any additional questions that you think of, feel free to send it to myself, Stu, anybody.